So you talked about sponge airport. You talked about digesting this rainwater. This is mainly conducted through an underground pipeline system. You're right. Our underground pipeline system is. I'm actually referring to the underground pipeline system under the terminal, and we see there is an entrance, and this will lead us to the underground pipeline system. Yes, this is the exit of this system, and the depth of bury is 8 meters, and the 9.3 meters in width. We have the pipelines for heat supply, for water supply, electricity, and also telecommunication. All this would be integrated into this underground pipeline system, and in the future, the operation of all these systems would be smart and intellectual. For the underground pipeline system, we have adopted some engineering technologies. For example, during the construction and engineering process, we have developed some integrated technologies, and we have with us a lot of models, and we can support production line style of engineering, and this can significantly reduce the labor input. And traditionally, we need 30 laborers to complete this work, but now I'm only using 8 people. And this is a significant reduction of labor inputs and improvements in efficiency. So right now we have entrance in front of us, and we tried to step down a little bit, and but when we were half down, the signal was losing, and so we can just stand out here and give you a panoramic view of this very magnificent bridge. And you can see it goes all the way to the terminal. And this is such a magnificent building connecting Beijing to the new terminal. And the overall scale and structure have taken shape. We were talking about the underground pipeline system. What's in it? What's integrated in that system? So does that mean that in the future there will be no electricity poles underground or pipeline water pipes on the ground? Yes, all the pipelines, they are buried underground, and they will be under unified deployment, and we will also support intellectual management for these systems. And for example, they can support heat supply, water supply, neutral water supply, electricity lines, and also telecommunication cables. And when this system is built, we will support smart monitoring and intellectual information management. And when the pipeline system is fully completed, it will dramatically enhance the scientific management of the terminal. How many poles like this do we have here under those bridges? We have altogether 375 poles like this. What is the tallest point of the bridge? And the tallest point is at the terminal section, and it's 20 meters high. So it's 20 meters at the section of the terminal building, so it's like a 3-story building. Yes, and but according to the overall architectural design, and the departure building is the 4th floor of the terminal. So what are those scaffolds for? Well, they will be removed after the bridge is fully completed. All right, let's get to the top. So a moment ago we were at the downstairs at the foot of the bridge, and now we will go on the top and see what it looks like from there. And just now, Chief Engineer Mr. Huang gave us an introduction of a miracle, a construction speed that is only possible in China. In other countries, it may take more than 10 years, but in China, it only took 3 years. How did you manage to finish such a magnificent scale of building within such a limited time? And we have so many buildings. And what is the secret behind the speed? Well, there are a lot of secrets behind this speed, and this is a systematic building. It's system engineering, and we have a lot of systems, and we are using the B-type engineering solution, which means that for all the construction work, all the organizations, and we have collated all those construction projects that can go parallel together. So this can significantly reduce the amount of time we spend. And what is this model in front of us? So this one is a 2-story building, and this is mainly for this is simply like the installation type of construction, and the government is giving us a lot of support. And well, this simply allows you to build up the building block by block, and you can quickly install a lot of major parts and blocks, and so that you don't need to build this building brick by brick, and you can complete finishing major blocks of the building and then transport them here and then get them installed and integrated together here. So how significant is this in saving time? Well, this depends. It depends on how prepared and ready that they were before transported here. But I can tell you at least we could save half of the time, and also we can further reduce the time because we are undergoing a lot of research and developments. And for example, this stairway, it can be installed directly here, and the poles, they can be transported here, and so it's very convenient and it's very fast, and we just need to put all those different blocks together to form a building. And after these blocks are put together into a model, and we can simply supplement the exterior wall, glass wall on the surface. Then what about decoration? For decoration, we could also have some prepared models, and even for the decoration of the bathroom. And when those blocks were at their manufacturing plants, and they were already driven holes, and everything is made ready. And right now, 70% of the buildings, they were actually pre-manufactured in the plants, and they were just transported here and installed on site at the terminal. So the overall equipment modeling rate has been significantly enhanced. And in China, we have precedence that a very tall building is completed within 1 month. So these are those blocks that you were talking about. Yes, these are the blocks that we're going to use in future engineering tasks, and after manufactured or processed in the plants, and they are transported right away to the sites. And it's just like playing Lego games, and we can use the weightlifters and forklifts, and they are very standard. And through the process of construction, we are engaged with continuous research and development, and we want to make this a standard process, and we are dramatically improving the overall process. So can you give us a brief demo of how you put the block on this building? It's very simple. For example, this one, this roof here. So for this pole, we can lift it up here and put it on a position, and then we can install this prepared, pre-manufactured beam on it. We just put it there, so it goes here as well. So in actual engineering process, we actually have very strict requirements. And when these beams are laid there perfectly, and then we are going to add the roof on it. This is simply like Lego games, and so you just need the and you just need the tower crane to put these blocks on position. This is simply like a Lego game that children play, and this will be an important direction in the future. So for this type of engineering approach, what is its most striking advantage compared to traditional construction approach? But I'm also concerned about security and safety. Well, you can stay assured that there wouldn't be any safety issues, and traditionally there were some concerns about structure, but from an architectural perspective, all the physics are there, and we have relevant strict requirements and standards. So there is no doubt that these buildings are safe and secure for anyone to live and work in. We already have in place a lot of regulations. As long as you are complying with the regulations, and then there is no such worries. So we see there are some boards introducing the application of new technologies. For example, we have here disc lock steel tubular scaffold. So what is this? This is like another Lego game? Well, this is a different type of scaffold building technology, and traditionally we built those scaffold structure one bar after another, but right now we have an overall integrated system which can reduce the amount of errors made by our workers. So do you number each and every part of the building so that you won't make a mistake? Yes, we live in a time of information, and all those blocks produced from the plants, they were numbered. They were given a code. So these codes are not just marked on the poles, but also included in our computer system. It's just like primary school students entering the classroom, knowing where he will be seated. And so for each pole and each block, we have a number, and this code goes to the coding system we have in our computer, so the accuracy rate is just very high. To give you a better understanding about these sites and this construction project, we have also prepared some video clips. We have some 3D cartoon clips. We also have some aero videos. And this is one of the techniques for the comprehensive pipeline system, and we dig out the dirt on the ground, and we are using this as part of the information and technology. We have a bogey system in place. It's just like taking the train, and the external structure can give you a model, and it's just like, you know, you're boarding on a train and you are making progress for meter by meter, and you don't need to get ready when the moment comes. You can just progress ahead without making any preparation, and this system allows you to dramatically reduce the amount of time of engineering. So these are some of the representative works of China Construction Corporation. The photo we just saw is the Tianjin cruise port, and this is the new airport in Tianjin, and we have been given the award of Luban Construction Award, and also the most recognized Zhan Tianyu Award. So these are some of the achievements from the past. What is this? Well, this is the Seaflower Islands in Hainan Province. Here we have the Wanda shopping mall, and it's using the element of porcelain. Well, this is a ski resort in Harbin, and this is the world's largest indoor ski resort. These are very beautiful, magnificent buildings. What is this? So you even designed the treasure golf of Disneyland? All right.
北京新机场的这个高架桥的这个主体工程、桥梁工程呢，刚才的仪式已经结束了。
All right, we have just given you a demo about the, give you an introduction about the bridge structure of the new terminal of Beijing Airport. And now let's take a look at the terminal building. All right, let's end this program here, and this is the end of this program today. Thank you very much for watching. Bye bye.